And I'll just start. So thanks everyone for coming. This is Android and VR with Cardboard and Tango. That's how it was listed. I'm generally going to give an intro to VR for those who are new to VR. How many here have tried some kind of VR before? Good. For those who haven't, I do have some demos. We'll see in a second. So what I want to talk about is not. Now it won't forward. Seem to have lost the keyboard due to USB Mac issue. If I can just forward with my mouse, that'd be great, but it's not doing that either. A complete restart.
The mouse just came off. The mouse just came off.
I've been trying plugging and unplugging the mouse to try to trigger it. Yeah. So I was trying to use a Chromecast to avoid the whole USB issue. While I reboot, so what I'm going to talk about is Cardboard. For those who haven't heard of Cardboard, it attaches to the phone, but I'm also going to talk about Tango, which is this tablet here. There's also a large headset that can attach to this, and I'll show a photo of that. I didn't bring it. Let's see, come on, power up, power up. It's powering up. So, just a little bit about myself. I'm Dario Laverde. I work for HTC as a developer evangelist by day. By night, I'm very involved with the Android community here in New York City. I run the New York City Google Developer Group. So we're constantly doing tutorials and hackathons and so forth, and a lot of these technologies. Recently, we had a Project Tango hackathon. I'm back. Let's just log in while before I connect it. Just checking the recovery for PowerPoint. And yes, it recovered. And I'll hook up, and we'll start. Okay, so Droidcon NYC. There it goes. I cut off the bottom because it's not pure 100% this talk. I will be talking about other things besides Android and VR, namely Unity. But if you haven't seen this Time magazine cover, I don't know what you think of it. It may be setting back virtual reality, or maybe not. But mainly, what I generally like to start with is talking about what AR and VR really are. It's the proper term, in my opinion, is mixed realities. Of course, it's too late to change that. But it's the whole continuum of reality to virtuality that we're talking about here. Because technically, you can have a headset that is AR and then have it remove opacity and becomes a VR headset. Or vice versa, you can have an enclosed headset and put cameras on it, and it suddenly becomes an AR headset too. It's really one continuum, and it depends on the level of reality versus complete virtuality that you want to do. When it comes to virtual, which we're going to focus on, it's all about presence. And what does that mean? That means feeling like you're actually in a quote-unquote real environment relative to how your experience and your inputs are telling you that you're experiencing something that you're aware of. In other words, being really present and not feeling nauseous. Now, a lot of the older VR, excuse me, that failed before was because it made people sick. Like, you couldn't last for like more than 10 minutes or even half hour in the older VRs. I'm talking about 90s. Now we've gotten our technologies to such a point where if you fulfill, at the very least, these specs here, you can actually experience presence. And these specs here are coincidentally the specs for one of the higher end VR headsets out there, the HTC Vive. Full disclosure, I work for HTC, but it's hard not to talk about the HTC Vive and Oculus and relative to all the VR offerings out there. If you haven't heard about Oculus, I'm sure everyone's heard about Oculus, but if you haven't heard about Vive, and the beginning of this year, after we announced it, it's been overwhelming. Every person that's demoed it, every person I've demoed it, it has had such a reaction. And it's mainly, like Time Magazine says here in the bottom, mind-blowing. Everyone's mind gets blown. Especially if you haven't revisited VR since the 90s, or if you're completely new to it, it's very, it's something you can't really describe. You actually have to experience it. And it's really dying to experience it, and you're a VR developer, see me afterwards. I could probably give you a demo. But the reason I bring Vive and Oculus up is because I like to describe VR in these three tiers, for lack of a better word. At the high end, we have tethered connections to the headsets. And why is that? Why can't we go wireless? Because the amount of data we're pumping for the resolutions that we have in those screens is just too high to make wireless right now. I'm sure that'll change over time, and we'll have full wireless experiences. But for right now, for both the HTC Vive and Oculus, you need to have a tethered PC, high-end PC, with a really, really hefty GPU card. On the middle tier, we have console machines like the Sony Morpheus. And of course, at the bottom, which is what we're going to talk about, we're going to have things like Cardboard and Gear VR, which rely on the portability of a phone. But unfortunately, the phones are not powerful enough to really give you true presence. Don't worry, that was just my mouse. So what I want to talk about that's across all tiers is how to design for VR. And a lot of this was mentioned by Google at their Google I/O talk, designing for VR, because they have lofty goals beyond cardboard, and as far as what the rumors go, and this is according to New York Times, who talked to some Googlers, they are working on like an Android VR OS or some sort. So whatever their grand plans are, they really made a big splash by having this really well, there was a panel discussing designing VR in a very broad sense. But what I want to talk about, of course, is just going back to the beginnings of understanding like stereoscopy and why we have it, why we need it, why 2 screens per eye, or 1 screen in the case of a phone. It's because of this parallax experience. When you have 2 eyes, you're going to see 2 different things. In fact, if you pay attention to whenever you have a 3D TV or even Google Maps, Street View, they didn't go around mapping things in stereoscopy. They did 1 camera. So now when you try to do stereoscopy, they're trying to fake it. So you can tell when something's been faked in stereoscopy by looking to see if they shifted the image left and right, or what. And the way you can tell, especially in Street View, is you can see around objects. So again, remember, 2 viewpoints. You can see occluding objects to the rest of the image, and that's how you can tell it's true stereoscopy. And all of that, of course, depends literally on the IPD, which is your interpupillary distance, which essentially is the distance between your pupils. And every headset, ideally, would be matched to your specific IPD for the best results, for the best stereoscopic results. Obviously, it's not possible. Sometimes people will go with the average number, and that's been always debatable because it seems like different genders, different races have different average IPDs. So ideally, you want to have an adjustable thing. And the high-end headsets, of course, have it adjustable. On the low end, so I didn't bring cardboard because I was bringing a lot of swag, which some of you got downstairs. And whenever I carry a couple of cardboards, because they're made out of cardboard, they crush easily. I found this cardboard equivalent, a company called Go4D. They are a certified cardboard distributor. So this works as a cardboard, and I usually put it on the phone as such, and then you can get, and I'll do some demos a little later. This is your easiest cardboard experience, easiest VR experience. And what I failed to mention before, when I was talking about different tiers, even Google considers this like a snackable, bite-sized experience of VR. They want to keep cardboard to be as simple as possible. So they don't want to keep adding input controls and so forth. They want it to be an intro, very snackable, bite-sized experience because they realize you can't really watch full-length movies on this or anything without feeling nauseous. So IPD, in this case, it's not adjustable. Some cardboards do have it adjustable. The way that you can measure your IPD, and I really like this this tool by Warby Parker. And essentially, it's a web page that turns a camera on, so you see yourself, and you can, relative to an object that has a known distance, like your credit card, it can accurately measure your IPD right from the web page and give you an exact number. And of course, once you have that exact number, you can actually, if the hardware provides it, measure exactly your IPD and get a much better experience. And that experience will come to play when we talk about convergence and focus in VR. Because as you know, it's all about, if you hold your finger and just look at your finger, the background seems to like double, and vice versa. If you hold your finger out and stare at your finger, the background will well, that's what I just said. If you look at the background, then you see two fingers. So getting the IPD is very important, and getting those effects within your app will lend to better presence and immersiveness. And the one thing about convergence and focus, of course, is that you can see a lot more detail with things that are closer than things that are much further. So you have to rethinking your gameplay about where objects are relative to the viewer. And of course, the most important thing you probably heard about this is field of view. How much of your view can you see? Obviously, we don't have perfect focus on the extreme points, the field of view angles. But just as equally as important as side to side is top and bottom. Ideally, you want 210 degrees by 100 degrees. And again, this is something that was recommended by some of the VR experts at Google, which is where I got some of these images from. So essentially, when people ask, well, what's the resolution of your headset? It's kind of the wrong question. What Google suggests is to think of it instead of field of view, think of it instead of resolution, think of it as degrees of field of view, but at pixels per angle. So let's say you do have the ideal, 100 by 210. You want to approximate reality as much as possible. Ideally, you want 60 pixels per angle. Now, that's difficult to do with today's technology, but of course, we're getting there as screens get, the densities get increase and increase. So for as realistic as possible, where you can't tell VR from VR, you would need minimally a 60 pixels per degree. So that's 1,200, 600 by 6,000. So it's a lot of pixels to push. So we're not quite there yet. Just by relative comparison, when you get only 12 pixels per degree, with the Nexus 5 cardboard, it's a much dramatic difference, as you can see. So it's all about field of view more so than what resolution. Now, the other primary thing about any VR headset, including cardboard, is the lens that you're using. Now, the whole purpose of this lens is to, of course, increase the field of view. However, by doing so, it's going to distort the image. And that's what we call the pincushion distortion effect. In order to compensate for the pincushion effect, you need to basically change your image to be using a barrel distortion effect programmatically at real time in software in order to offset the lens effect. And that's why each headset has to compensate for its particular lens. So in the case of cardboard, so since every manufacturer of cardboard, whether you do it yourself or purchase one like this, it has to provide the information with the lens to accurately create the barrel distortion at runtime. And for that, that's why you have to register each one with Google with a QR code so that you can have that information as part of the Cardboard SDK. And then normally you don't have to worry about it. The Cardboard SDK will take care of that for you. But that's why you need to register with that. I'm going to quickly move on. Designing for VR, we want to basically the most important thing is not to drop frames. I mentioned that earlier. Also, transitions should be fade to black or fade to white. Use audio cues. Don't do things like sometimes start the game and you're in the middle of an object. That's very disconcerting and breaks and takes, the presence away. Fix the velocity, brightness of changes. Anything that's not realistic which is different from when you create 2D games. Gamers are used to seeing the screen flash and shake and so forth. When you're immersed in 3D, when you're inside the actual environment, none of those tricks work anymore. Those are all the don'ts. Some of the do's is to be able to bring people to places they can never otherwise be, to experience things. Now, there's this cardboard app called Cardboard, which is about falling, and it's just continually falling. Obviously, if you have a fear of heights, it's an issue. But that aside, that's, again, giving you experiences you can never have in real life otherwise. So that's one of the pros of VR. Some additional tips. When you try to direct, remember, they're free to look anywhere whenever you're in the VR experience. So you have to remember, if you want to direct them to a certain place, you have to give them little hints. And you can use little, a reticle. That's the definition of a reticle there, is you literally point to where they should look at. But you can also have, for example, guide them with light effect, guide them with objects that glow, or little subtle clues as or have your animated character move a certain way or suddenly start moving to give the user direction. Now, there's a lot of best practices in a lot of sites, and I've been to a lot of VR talks. Hopefully everyone can agree to consolidate them in one place. There was a list from Unreal Engine VR folk that I thought was really good to point out some of these. Anything that has cinematic effects doesn't really translate to VR. So for example, Google has that storytelling series where they made these short films, and it works great on the phone. It's not going to necessarily translate directly to VR. Although they're trying to work on that, because a lot of the times the camera will, instead of having a cue like a reticle or a light to tell you, go look it this way, they're actually moving the camera for you and speeding it along the storyline. That's going to cause a little nausea for people, so that's something you have to take care of. A lot of the effects in 3D first-person shooters, and recently I was working on a first-person shooter where by default they like to bob the camera and make it look like you're walking. Eliminate those. A lot of those tricks don't work in VR. Here's some more, and again, the slides will be available so you can reference it. But what I want to talk about now, instead of the generic VR best practices, is let's just talk about cardboard specifically. Again, one of the best things about cardboard is its cost. It's do it yourself, or you buy it for $15 or even less. Or you can use open source plans to 3D print it. Now, this past Google I/O, they released version 2 of the cardboards. And it's very subtle, minor differences. Now, the main thing was the input is now by having the button pressed at the screen. So instead of using a magnet as the input switch, they're having the button actually depress the screen. That helped a lot of issues where the magnet wasn't working for a lot of phones. So they have their guidelines for Cardboard. Again, a lot of best practices overlap across all the tiers of VR, but they have an app that illustrates their specific ones they recommend, these 10, for Cardboard specifically. So a lot of these we mentioned, but it's great if you haven't tried Cardboard to actually download that app from the Play Store and check out all these principles. For designing the apps themselves, there's some guidelines as far as how you should reference Cardboard, the trademark. Instead, you should mention Cardboard instead of virtual reality, which I kind of agree, because it's not really true virtual reality. But always also make it so that the app can sort of work without having Cardboard. So they recommend that you should get Cardboard, but you can also switch to like 2D for some of these apps. 3D positional audio. So it's been available, and it's available in Android using OpenSLES. So there are a few libraries out there that you can purchase to get that. It's very important to realize audio's importance in VR, because now you can have 3D sound direct you to where you want to go or what's happening around you. Specifically for the SDK, like I mentioned, it provides this distortion correction. It provides head tracking using a accelerometer, and it provides your basic parts of VR, including the single input handling. It's just a few classes. If you're doing this in Android for Java, the Java API, you're essentially going to focus on the stereo renderer. These are the main methods in there. I'm going to switch to walking through it in a minute. The SDK sample. Actually, let's go to code. That's right. Everything crashed. I have to open it up again. So Cardboard Java. So how many here are familiar with OpenGL? Just curious, just a few. Basically, this app, what it does, and I don't know if I should try. Maybe I won't try it to do a demo, but I'll just go back to that screenshot. So what it does is you just have a single cube and a plane, and the cube appears randomly every time you look at it, and that's how you center it on your screen, so when you look at it, it gets selected, it changes color, shown on the right here, and then you get a point where every time you look at it, because it'll disappear, and it'll be like a little mini game in a way that it'll randomly appear elsewhere, and you have to go around looking for it up and down, left and right. So it makes use of VR that way. Essentially, this is the main method, the onDraw eye. So you have each eye drawn. If those familiar with OpenGL, you usually have onDraw. You are using the onDraw eye instead because it takes care of managing, all the lens effects and filters you need to do to make it look right under the covers for you. So most of your OpenGL code for existing games can work. Just port it over to the right methods. This is essentially this 6-point checklist, which I recommend. Currently, Cardboard requires Min SDK version 16. You require to specify this uses feature OpenGL for that version. And then it's a matter of using this intent filter, the Cardboard activity instead of activity, and then you're going to implement this stereo render, which I showed you some methods earlier, and the Cardboard view itself, which it extends surface view, so it's going to, instead of using surface view, it's recommended to use Cardboard view again for it to take care of all the underpinnings of what's happening with the stereoscopy and so forth. This is essentially how your onCreate will look like. It's a minor setup. Normally you have a surface view anyway, so you're going to be replacing that on your layouts as well with Cardboard view. You're going to initialize the render for that view, and pretty much it's like most games and OpenGL apps that kind of remain the same except for these new interfaces. then you associate the activity with that. And again, this is a cardboard activity. There are some, if you need to do some specific things, it gives you like manage how your head is moving or do something else to get an input from your head movement, although I wouldn't. You have ability to do that with these additional methods like on new frame. And like I mentioned earlier, excuse me, they changed the way you have some of these the input to Cardboard, but it's backwards compatible, so that before you used to use the magnet, now uses the screen. The code still works the same way it did before. You have is looking at object method, so that you can use that as an input. Remember, that's if you center the object to be selected in your field of view. That's another type of input. So technically, you have two inputs. Actually, right now I want to be able to switch to the tablet to show you some things, because fortunately, this Tango tablet has an HDMI output direct from the tablet, so I don't have to use any tricks with, as I did with the phone, which caused the whole problem and why Chromecast didn't work. So I'm just going to quickly switch over to show you some games that I've been porting, that we're done in the process of porting. There's this open source game called Seven Wonders that we a small group of us who run. I run an Android study group as part of the Google Developer Group here in New York, and we've been working on this app for quite a number of years. It's just a simple 3D OpenGL, but now we've been porting it to different platforms, and now most recently to Cardboard and to Tango. So I wanted to show an example of that running, and as well as a few other apps on Tango. So I'm going to switch the input. Now I'm kind of switching gears to talk about Tango, although I'm not ready to talk about it yet because I'm still on Cardboard. But I just wanted to show you, essentially Cardboard technically does run on Tango. And when you run Cardboard, you have this app, and you can configure which device, Cardboard or headset you're going to use with your Android device. There's a number of demos here. This is usually how Cardboard app menu is displayed to you. So as you can see, as I center it, it's going to select different apps and so forth. So I'm going to try to center it on, for example, I don't know, this. And then you can see, in this example, pretend you're in a museum app where you can actually look at objects and go around them and underneath them and so forth. So that's an example of what you could do with Cardboard. Let me just exit this. So what I was talking about was this open source game. I think I have it in here. So the first approach you can do when you're trying to port something is maybe you can, if Cardboard seems like a lot of work to port to, you can just simply try creating a second view on the second half of the screen. So that was this is the first attempt at it, where you have, so here you're flying on a magic carpet and trying to collect things in this world. But as you can see, some of the things are not stereoscopic. So it's a lot more work if you want to actually do your own IPD and do your own split screens for stereoscopic than it is to port to Cardboard. So when you're porting a game, what I recommend, let me just get out of here and switch back to the slides. So the reason why I was just talking about the first attempt. Just add a second camera and see if that'll do it. But it doesn't account for a lot of these issues which Cardboard SDK will solve for you, and that's providing that on-draw eye method that allows you to have, you know, adjustable distance between the eyes. 3D texts or toasts are automatically taken care of to be stereoscopic for you. Handling input, well, in this case, we had programmed this so that you can use the accelerometer and the D-pad, so it was okay. So you have to start considering that even though we use the accelerometer, we had used it like up and down to speed up and slow down. That no longer works in VR because you're going to be immersed. So if you look up, you should see what's up, and look down, you should see what's down. So some of those are the considerations when you're porting an existing game to use a Cardboard SDK or VR in general. Oh, okay, so I'm going to switch back to Tango tablet to show you a little more about, yeah, I should have shown you that Cardboard app. Yeah, I'll do that now. So Cardboard has APIs for Java and for Unity. So the Unity one's actually a little different. It tries to use some of the effects that's easily implemented in Unity that would be a lot more work in OpenGL. So just give me a second. I'm looking for the maybe I don't have it here. Actually, this would be a good point to actually run it from the IDE. Sorry for the delays here. I want to show you the Cardboard using Unity. I thought I had it here. It would have a Unity icon. Yeah, it's a different demo. It's not Cardboard. It would say Cardboard with the Unity thing. But anyway, while I'm here, I might as well show you some Tango demos. So I'll just pick some of them that are available in the store. So again, a lot of the apps you'll start seeing are made in Unity because it's a lot easier so far as amount of coding to do for Unity versus OpenGL. Here in this example, it allows multiplayers to be in the same space. And again, what Tango does is introduce the whole concept of depth. So it has special motion tracking sensors and ability to create depth maps so it can recognize objects in a room. In this case, it's just simply motion tracking wherever I'm going. So if I had another player there, I can actually walk around them. So it's not a stationary, standing or seating experience anymore. It allows you to move about and walk about. And in this case, with the dual screen with VR, but of course, you can just make this a single screen for those who don't have a headset. I am going to switch back to the slides. If you have any questions, feel free to ask.
I'm not sure
Yeah.
if I'm not paying enough attention, but I'm struggling. What's the difference between Tango and Cardboard?
So Tango gives you additional sensors. It's got, I'll actually have a slide for that. That's why I switched back. Let me just skip to Tango. Yeah, I'm getting to it. What I wanted to talk about with I'm just to finish Cardboard. I'm going to finish on Cardboard first before I switch to Tango. The reason I'm bringing up the tablet is because if you're on Cardboard, there is no known headsets that have that URL. Just to back up a bit, whenever you run in the Cardboard app, you'll see this little gear in the middle. That little gear is what prompts you to scan in the QR code on your glass. So it would scan it on here, and then it would know what IPD it is, what lens type, and so forth. So the Dive headset, which is the headset for the tablet, for 7-inch tablets, is not certified. So that you have to actually go and do some workarounds. Basically create your own, it saves a file to your SD card. You have to create, these are the steps you have to do to create your own file for an unregistered or uncertified headset. So, Project Tango. So it's got these motion tracking camera, integrated depth sensing. So you can actually map the objects in a room and have area learning. And so that's what the headset looks like for for 7-inch tablets, not just Tango. So it's great for motion tracking, area learning, so it could do indoor location mapping, and of course depth perception. So you can do measurements, I've seen apps where they try to fit furniture into potential furniture you can buy into your house, so you can measure these things using Tango and visualize that using AR and VR. And that's not, Project Tango is not just going to be available in tablet form, it's going to be available soon in phone factor. So with the phone, Qualcomm and Intel just announced it as well. We're going to see that very soon. In fact, they mentioned it this summer. Okay, so I'm going to let's do the slides, finish the slides first, and then go back to demos. So VR, so Tango has a separate SDK, and they're working on integrating VR with that SDK, primarily in Unity. So, and that's still experimental only. For those who haven't seen Unity, I'll just switch to Unity right now. I'd have to open it up. All right, so this is Unity here. Just a little quick overview for those who've never seen Unity. So you have the ability to edit a scene. Scenes comprise a project. Each scene is worked on separately from other scenes. So here we have a default scene with a camera and a light source. So I have the ability to, this is I'm going back to Cardboard, the ability to use prefabricated objects in my project that I take from the SDK and I can add it to my scene. So for example, this demo scene. So this is what it looks like for Unity. I talked about what it looked like for Android. This is the cube that you're going to look at, and so forth. Technically, you can play this inside your editor here. So you can see there's a little more effects than the Android version. With the Unity version, there's these little, little effects. You can't really navigate here because this is using APIs that only work on the Android device. But you can get an idea as you're creating your scenes how that looks like. Now, if that was Cardboard, I can open up a project for Tango itself. Let me just find the Tango project. Now, the Tango project is still going through a lot of updates. Each build and the ROM build that they do, they update the SDK, so some things break and so forth. In this example, I'm going to take I'm going to try to create on the fly here an app that actually runs on the Tango tablet. So they also have prefabricated objects that you can use. Like Tango Manager and so forth. But what I want to see if I can find the VR example. In any case, it was experimental, and let me go back to this. Let me finish the slides and then go back. And there's still bugs with it. And right now, also the other problem is that they don't really have a VR support for the Tango SDK directly. So what I did was I found a workaround where I mixed the Cardboard SDK and the Tango SDK using these steps. And I have a link to a full blog that talks about how to do this. But it is possible using a combination of Cardboard SDK and Tango SDK to get VR working on the Tango tablet. Let me see if I don't think I skipped anything else previous to this. I'm trying to wrap up because I know time is short. All right, so I discussed how it's getting to a point where you're going to see more. You're seeing more examples for Tango and Cardboard written in Unity than in just Java/Android. What I recommend is not to forget Android. This is an Android conference, of course. But if you're new to OpenGL and if you want to start from scratch writing a 3D, immersive first-person shooter, you try to learn Unity. It's time. I was resistant to it initially, but it really makes it a lot easier to prototype, even if you want to do a native 3D using a different 3D engine. For prototyping, it's great to use Unity. There's a lot of resources, fortunately, that are really good. The tutorials from Unity themselves are excellent. They even have a free roadshow and so forth. I've been, again, involved with learning Unity with the GDG group. So if you're local to New York City, stay tuned or try to join our study group. Adding or mixing Android and Unity. So it's possible. It's been done for a while. You're able to write your own plugins for Unity, and therefore you can add support for APIs that are not native in Unity yet, although they're always improving their Android support. There are some APIs, obviously, is always going to be in catch-up mode. A lot of new APIs, like the new Bluetooth LE, or if you want to, let's say, introduce beacons so that your VR world can recognize them in your real world. You probably need to write a Unity plugin at this point. It's not that difficult. There's a lot of sample code on how to write Unity plugins. It involves JNI, of course. But they also provide direct to Java access through their C# scripts. So the only thing to watch out for in general is mapping coordinate systems. Like Tango has its own coordinate system. Unity has its own coordinate system. And so there's some cases where you need to do a lot of heavy matrix math, including quaternions here. But there's some guidelines, and there's a lot of actual libraries that will help you. All the SDKs have methods to take care of a lot of that pain for you. Just a little more detail. If you want to mix Android code and call Android code from Unity and vice versa, they provide an Android JNI wrapper so your scripts can more easily interface with your native code that you're calling from Android. And even on the Android side, Android Studio 1.3 now has JNI support so that actually you can debug in native code within Android Studio and never leave that environment. In fact, they even have new autocompletes to fill in the methods for you so that you don't have to worry about that. Other open source initiatives, just to wrap up my slides, there's OpenVR and there's open source VR. There are two different companies, and basically what open source VR intends to do is provide a full open source stack, not just the software, but the hardware as well. All the hardware you can build yourself. The software is targeting all the existing headsets, including Oculus and Vive and so forth. The other one is from Valve Software, which is working with HTC on the Vive, but they've opened it up so that you can also support Oculus and most headsets. It provides additional features such as if you have room scale VR, it provides the boundaries for you so you can actually are aware of when you're close to a wall, otherwise you'll hit them. And there's going to be support for other platforms soon. I was just mentioning tracking systems. So when you have the ability, like in Tango or the HTC Vive, to move around the room, you need a tracking system. With Tango, of course, you can use the depth mapping and motion detection. With the Vive, you would use a lighthouse laser system, which would work similar to this. But I guess there's one more topic I want to talk about before I kind of wrap it up. Yeah, it's after? All right, I'm talking about video, open VR. I mean, VR and 360 video. 360 videos right now lack presence for the most part, so it's not really immersive enough. However, there are some examples where I know Microsoft Research is doing a lot of great examples where they map all the...
Hey, her talk's supposed to start in 15 seconds. That's all.
Okay.
She hasn't set time, so that's...
Thanks everyone for coming. There's additional resources available, and I'm available for any questions and answers.